Measures of central tendency. So this is lesson 3. In our day-to-day activities, we deal with many problems that involve related items of numerical information, and that's our data. Statistics is the study of the sense of that data. And then when we gather those numbers, besides displaying it, we often want to know a single number that represents this data. Okay, so we've taken lists of data and we've put them in different types of graphs. And now sometimes we just want a single number that could tell us something about a list of data. And that single number, there's a couple of them that we'll work with, have the umbrella term measures of central tendency. And the two most popular that we'll spend time with of measures of central tendency are the mean and the median. And you guys are both familiar with, or you're all familiar with the mean and the median. So exercise 1 says a survey was taken amongst 12 people on the number of passwords that they currently remember. The results in ascending order, so they put them in order for us, and we've got to find the median and the mean to the nearest 10. So go ahead and do that calculation. All right, so after that calculation, we see that, okay, the mean, 2.4, the median, 2.5. Would we agree that those two numbers are really close to each other? Yeah. So now the key is when the mean and the median are really close to one another, that means that the data is approaching very symmetrical data. When the mean and the median are further apart from each other, that means that the data is skewed. Skewed meaning a big chunk of it is to the right or a big chunk of it is to the left. Okay, symmetrical means it's pretty even on one side as it is on the other. So now it says, in exercise 2, it says, students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. So they collected information on 20 vehicles and put that information in a table now. So in exercise 1, we had a list. Now we've taken this information, because now we have 20 pieces of data, and put it in a table. Now, before you do any calculation on the mean and the median, because it's not in a list, I'm going to do something a little bit different here. So when I look at my table, how many cars were going 35 miles per hour? 5. So how many cars were going 39 miles per hour? Anybody? 2. So, all right. So now what we need to do is, if we were to string out this big long list, we have 5 35s, right? And 3 36s. So I'm going to have the calculator do that work for us. So this right here, the second column, this number of cars, this is a frequency column. It means there's 129 and 2 33s and so on. So let's go to the calculator, okay, and enter our information. So when you go to the calculator, make sure you go to the home screen, okay? This is key right now, especially if you're using one of my calculators so the data gets cleared out. Go to the home screen, new document, don't save anything, okay? So click no. And we've got to put our information in lists and spreadsheets, okay? So number 4. The list and spreadsheets works just like an Excel spreadsheet on the computer. And we've got to title the lists. So right now you need to be in cell A, and we're going to put our first list in there. And our first list is speed in miles per hour. That takes too long to write, so I'm just going to call it X. And then when I enter down or arrow down, I end up in that equal box. We will not ever enter anything in the equal box in this course. Okay, you don't want to put anything in the equal box right now. Okay, so now you need to be in cell 1. So we just go through and we enter the speeds exactly the way they are in the table. So after each one, hit enter. Make sure after the last one in the list, you hit enter. Because if you don't hit enter, the calculator hasn't taken it into its memory. Okay, you need to make sure you hit enter, or else as we go on, you'll get an error message. Now we've got to enter in our second list, which is the number of cars. So go up into the B cell, and I'm not going to title it number of cars. What do you think I'm going to title it?
Y.
Yeah. Okay. Again, don't be in the equal sign cell. Make sure you're in cell 1 and go ahead and enter in those frequencies. And again, make sure you hit enter after that last one in the list. So now what we want to look at is we're going to go to, we just want to get mean and median. That's all we want to look at right now. So we're going to go to menu, the menu key. And we're going to go to statistics 4. And then stat calculations 1. And now we don't have one variable, but we have 2. Okay, because we have 2 lists. Now, it comes up with X list. What did we title our X list? X. What did we title our Y list, or our second list? Y. Now, the next one down, it says frequency list. Our frequency list was our second list. Remember the number of cars? So what did we title our frequency list? Y. So you're going to change that one and you're going to call it Y. And that's all we need to enter, so you can just click on OK. So now it brings you back to your list in spreadsheets, and it gives you all of this information. So if you could arrow up to column C, row 1 there, that cell, it says title. Now all of these underneath the title are math symbols, and they represent something. So this one that's under the title, it has a really incredible name, and it's called X bar. That's all it is. X bar. What does X bar stand for? X bar stands for the mean. Okay, so X bar, so if you look next to it, what is the mean for this data? 36.1. And now, if you scroll down through the title list, all the way until you find median. So what is the median for this data? 35. So now you can see in here, you've got all this other information. You've got your min, you've got your quartile 1, your median, your quartile 3, your max, and then there's obviously other information in there that we don't know just yet. Okay, Michael?
What about the median Y?
No, we're just focusing in on the median X, because remember that Y list was our frequency list. It's the number of cars that were traveling at that speed. We're interested in the speeds. Okay? Awesome question. So let's go back and write in. So the mean was 36.1. And the median was, what was it, 35? So now, the mean and the median for this data is not as close as the one that we saw in our first example. So our data isn't as symmetrical as the first set of data would be. Now it says the speed limit along this part of the highway is 35 miles per hour. Based on your results from Part A, okay, is it fair to make a conclusion that the average driver does speed on this roadway? Is it fair to say that the average driver, average means the what? The mean. But think about that for a second. Is it fair to say that the average driver speeds? Okay. look at your data. 35 miles per hour. How many people didn't speed? 12 people didn't speed out of 20 people. More than 50% of the people didn't speed. So is it fair to say that the average person speeds here? No. What's going on? Kenny? This guy right here. He had someplace important to go. Okay? 54 miles per hour. Almost 20 miles per hour over the speed limit. So kind of an outlier there. What is that 54 doing to the mean? No. Okay. All right. So no, it is not fair to say the average person speeds, because we looked and we found 12 out of 20, okay, traveled at the speed limit or less. Okay, and we noticed the outlier, which was 54, I pulled the mean up. Okay. So it's important to really look at what those numbers mean. Okay, can't and don't be misled. Okay, look deeper into the numbers to make conclusions. Okay. So on the next page it says, when conducting a statistical study, it's not always possible to obtain information about every single person or situation to which the study applies. It says, unlike a census, okay, a census finds information about every person, where every person is counted. Some studies, most studies, okay, use only a sample or a portion of the items being investigated. Whenever a sample is taken, it is vital to be fair. Okay, and in other words, the sample needs to reflect the overall population. Okay, so we don't want bias in our selection for our sample. We want it to represent all. In exercise 3, it says, to determine which television programs are most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside of which of the following locations would the interviewer be most likely to find a fair sample? Explain your choice and why the others are inappropriate. So, trying to find information about which television programs are the most popular. Next, what do you think?
I think that the grocery store would be the fairest, because if it was in a baseball stadium, they'd favor like sports. At like a concert hall, they might favor like music channels and
Yeah.
comedy.
Late night comedy kind
They
of.
might just favor like comedy stuff on TV.
Yeah, absolutely. The grocery store, who comes out of the grocery store? Everybody. Okay? So if you are looking for information about which television programs are most popular, that's going to give you the most random, okay, sample, representative of the population. All right. Next one. So now we're trying to determine the average height of high school male students. Because he is on the basketball team, he uses the heights of 14 players on the team. So they're given, and they are in order from least to greatest. So we want to calculate the mean and the median for this data, and we've got to round anything to the nearest tenth. So you can decide whether you want to calculate the mean and the median by hand, or if you want to use the calculator. It doesn't matter, okay? If you choose to use the calculator, you're only going to have one list. You're going to list it in one X list, and then you're going to pick one variable statistic instead of two variable statistics on the calculator. Okay? We'll pause so we can do that calculation. Mean 74.6, median 74.5. Would you say that this data is symmetrical? Yeah. Okay, because those two are very close. Okay, very close to each other. So is the data set above a fair sample to use to determine the average heights of high school males? Madeline?
No, because a lot of basketball players are really tall.
Okay, absolutely. Okay. No, because many basketball players are tall. Okay. Data sets can have members that are far away from all of the rest of the data. These elements are called outliers. You guys know that. Okay. Which can result in a mean that doesn't represent the average. Okay. Because we know if you have an outlier that's really high, it's going to pull the mean up. But if you have an outlier that's really low, what's it going to do to the mean? Down. Okay, and in this case, looking at that data for some test grades, the outlier is what? Is it low or high? Low. So what's that going to do to the mean? It's going to pull it down. Okay? So calculate the mean and the median for this data set. Which score is the outlier? We came up with that, 45. You guys know by now how to calculate these two. The mean should be, does it say what's rounded to? No. 81.75, and the median equals 86. Okay, so you can see those two are not close to each other. 81.5 and 86 are far apart. Okay, that is not symmetrical. We got something going on in there. And we see that that outlier of 45, and see what that 45 did to the mean, okay, compared to the median. Which value, the mean or the median, is the better measure to tell how the average student did? Which one's a better measure to tell overall than the median?